All right, so in this video, we're going to move on to 1.6, and we're going to define what an inverse function is and what are the characteristics of inverse functions. All right, so I'm going to start with the definition. It says for functions f and g, if 1 and 2, okay, so two things need to be true. If I do the function composition, if f of g of x is equal to x for every x in the domain of G, and G of f of x is also equal to x for every x in the domain of f. Okay, so in other words, every x in the domain of my input function for number 2, every x in the domain of the input function for number 1. If these two conditions are met, then what I can say is that f and g are inverses of each other. Okay, so that's the definition. If I do the function composition one way and I get the identity function, this x right here is called the identity function. And if I do the function composition the other way, I also get the identity function. Then f and g are inverses. Okay, so remember in general I said f of g of x does not equal g of f of x. But if they actually do, right, if they both equal each other, in this case, if they both equal x, then they're inverses. The alternative way of writing this, you could write it like this, or number 1 or number 2, right? You could write it like this. F of f inverse of x is equal to x, or f inverse of f of x is equal to x. Okay, so this is another way of writing this. And then remember, this is your inverse notation, right? This reads f inverse. Okay, so that -1 does not mean, it does not mean -1 exponent, okay? It just reads f inverse. Okay, so that's the definition. Now let's take a look at some properties of inverse functions. Properties. Okay, and I will have 3 of them here listed for you. The first thing that you'll notice about inverses and inverse function is that their coordinates, okay, their coordinates are switched, or you can call it interchanged. Okay, so for example, let's say if f has the coordinate a comma b, then x comma g will have the coordinate b comma a. Okay, or, the alternative notation is, let's say I have x, here's f, here's a, here's b, and I have x, here's f inverse, right? B and A are interchanged. Okay, so the coordinates are switched between a function and its inverse. Not only the coordinates switched, right? The domain and range are also interchanged. Okay, so I'm going to use a different vocabulary word here. Interchange instead of switch. What does that mean? It means that the domain of f is equal to the range of g, okay, assuming that f and g are inverses, and then the range of f is equal to the domain of g. All right, so coordinate switch, domain and range interchange. What else? Graphically, something is true. Well, let's illustrate this graphically before I tell you what is true about characteristic number 3. Or here we go. Let's say I give you f of x is equal to x squared, or actually we'll call it square root of x. If I were to ask you to plot this, right? You maybe might make a few points here. Here's x, here's f, here's 0, square root of 4 is just 2. Okay, if I asked you to calculate the domain, right, you would say x is greater than or equal to 0, and then the range is also y is greater than or equal to 0. Okay, the graph will look something like this. If I graph it in the first quadrant, 1, 2, 3, 4, 1, 2, 3, 4, 0, 0, 4, comma, 2. Right, there's my square root function. There's the domain, right? X is greater than or equal to 0. There's f. All right, now how do I obtain my inverse? Remember, the inverse, let's use some characteristics that we've just studied. We know that for the inverse function, right, these coordinates interchange. 0, 0 just becomes 0, 0. 4, 2 actually becomes 2, 4. So 0, 0, 2, comma, 4 would be right over here. And if you were to connect it, it would look something like this. And actually, if I ask you what is the domain and range of the inverse function, the domain is the range of the original function. The range of the original function of f is y is greater than or equal to 0. That means the domain would have to be x is greater than or equal to 0. I know it's hard to see the interchange this time because everything says it's greater than or equal to 0. But if you could just pay close attention, the range of f inverse is the domain of my original function, right? The domain of my original function of f is x is greater than or equal to 0. That means the range has to be y is greater than or equal to 0. So you might ask yourself, what is the opposite? I think one of the questions in your first examples and also in your homework is informally calculate the inverse function just by looking at it, right? What is the opposite of taking the square root of a function? Well, the opposite of taking the square root is taking the square. So instead of taking the square root of x, I'm going to square x. And actually, this is my inverse. F inverse of x is x squared. Okay? So this is my f inverse function. All right, now, graphically, what's the point? The point is that when you graph a function and its inverse, you will notice that it's a reflection over the line y is equal to x. Okay? Graphically, f and f inverse, or you can call it f and g. In this case, I use f and f inverse, are reflected over the line y is equal to x. Okay, so this last example, or point number 3, kind of just summarized what I said in 1 and 2, right? The coordinates are interchanged, domain and range are interchanged. I even informally calculated the inverse function with you in my head. What's the opposite of taking the square root of something? Well, the opposite of taking the square root is squaring. So there's my inverse. And then you can see graphically that it's a reflection